What motivates me to work with new materials is working at the intersection between science, technology, and practical applications.
My role in the company and how I help to bring the mission to life is about building a really strong and capable team of scientists and engineers who are capable of developing the technology in real-world applications.
What I enjoy most about working at Auxetec is the challenge. These are very novel materials. They combine liquid crystal science and polymer science in a very interesting way.
The teamwork here is in two parts. The first is taking the wonderful research and inventions of Professor Helen Gleason's research group at Leeds University, and the second is with industrial partnerships. This material has its biggest impact in materials and industries where we have early in-service failure due to delamination and impact.
Be it from large-scale wind turbine blades, for instance, to small-scale portable electronics, the impact-resistant application spaces of Auxetec materials are groundbreaking.
So the auxetic response of our polymers benefits users because when it is impacted or stressed, our material fights back rather than deforms like a conventional material would.
Auxetic materials are really unusual. When you stretch them, they actually get thicker rather than thinner. If you compare this with stretching a rubber band, this will be getting thinner as I'm pulling it apart. This is getting thicker. And these lattice-type structures are used already in industrial applications, are used in sportswear. Our materials are actually slightly different to this in that the auxetic effect happens at the molecular level and they maintain their density when they're stretched. This unique patented property enables them to fight back against impact. So we make very thin films, which makes them great in applications such as glass protection, where optical clarity is important.
So our materials being films allows us to apply our materials essentially wherever a film could go. When you need that impact protection and the usual solutions are much larger materials, our materials are thin, but they provide the same impact resistance.
We are able to control the dimensions of our films to tailor to specific customer needs.
They are fundamentally polymers. We can tune these materials in the same way as you tune any other polymer. We can change the elastic modulus, we can change the glass transition temperatures. Any polymer properties we can change while still maintaining the auxetic effect. The major milestones of working at Auxetec have been taking a small-scale technology that's come out of a lab in a university
to now using industrial coating techniques to make our materials on a larger scale.
And that's really important to our potential partners to prove that we can scale up without having to invent a new machine. That de-risks the process.
Our materials in the form of a film, we can of course apply that into various different application spaces, be it onto glass or be it onto, let's say, a composite for a wind turbine blade.
And when they're integrated into other systems, that causes those systems to last longer and resist impact and delamination.